Second section of 10.3 is distribute and rationalize. Hopefully you used your experiences last week. I think it was last week. I don't know. To get a grasp on multiplying radicals. If not, you still have a shot at success. You will have 2 more days in this section. And there is a series of review days coming up next week. Just be sure, again, this is your only weakness and that you'll have time to fix it. This first part of our lesson is the extension of the distributive property. Because we've done it in another chapter, we will not spend a lot of time on it. Please take solid notes and ask as many questions as you need. So we learned how to do a one-value distributive, but the same thing works whenever we do this. So you will actually do what you like to call, or some people like to call, the FOIL method with it. But again, just take your time and make sure you think. Outside is 3. Inside is 36. That's going to be negative because it's positive times a negative. There are no outside numbers. It's only 6 times 5 on the inside, which is 30. Here, outside numbers is 6. Inside numbers is 30. This is going to be negative. Outside numbers are 2. Inside numbers are 5 times 5, which is 25. Now, last time I did this, I actually wrote it out. But once I know what's going on, I'm just going to change the number. 36, square root of 36 is 6. And so therefore this would actually just turn into a 6 times 3, which is 18. Let me say that again. Square root of 36 is 6. That being a perfect 6 times 3 makes 18. 30, 4 doesn't go, 9 doesn't go, 25 doesn't go, 49 doesn't go, which means it doesn't go there either. So therefore we can actually put these two things together. Because they're both 30s, negative 1 plus 6 makes 5 root 30, if you remember putting like terms together. And then the square root of 25 is 5. 5 times 2 makes 10, so it should be minus 10. And the last step is you have 2 like terms here, 18 minus 10, which would be 8 plus 5 root 30. That is the job you are doing. Again, hopefully you got used to simplifying because that has to be part of your habit now. Otherwise, you're going to have issues answering some of these things because, again, that has to be done. There's no choice on that. Root 7 plus 8 times root 7 plus 8. I'm sorry, root 7 plus 8 times root 7 minus 8. First times first to root 49. First times that would be minus 8 root 7. This would be plus because it's positive, 8 root 7 because they don't mix, and then minus 8 times 8, which is 64. Square root of 49 turns into 7. Funny thing about this is that the negative 8 and positive 8 root 7 actually cancels out because they are opposites. Don't just always assume they're going to cancel, but when you have a negative 8 root 7, positive 8 root 7, those are gone. Minus 64, and 7 minus 64, I believe, is negative 57. This is special because you call this, what we'll call this tomorrow, a conjugate. And a conjugate is whenever you have the same values, but just a plus or minus. I don't know if you remember how whenever we multiplied x plus 2 times x minus 2, our answer was x squared minus 4 because our middle terms are x's because it's minus 2x plus 2x canceled out. But that's what a conjugate is. And we'll be using that actually, I believe, tomorrow when we go to do the rationalizing of the highest level. So rationalizing, some of the rules on your math career is, number 1, you could not have negative exponents allowed in your final answer. That is a rule. You'll never break that. The second rule is no radicals are allowed in the denominator of a fraction. And that is what we call rationalizing the denominator. So anytime you have an answer and there's a radical in the fraction, you have to, or in the bottom of the fraction, you actually have to fix it. We don't care if it's on top, it cannot be on the bottom. So how do you fix a radical that's on the bottom? Well, you use the rule that if you multiply a root by itself, it actually goes away. So what we would do here is we would multiply the bottom by root 2 because that's going to eliminate it. Unfortunately, if we just multiply by root 2, we're going to change the whole value of this fraction. So in order to keep things balanced, we are going to actually put root 2 over root 2 because what is the value of, and I know you should know it, but let's just make it legal, officially legal, so you know I'm not lying to you. Root 2 divided by root 2 is 1. And whenever you multiply something by 1, remember it stays the same. So we're really not changing anything because this equals 1 altogether. So all we're doing is giving it a facelift. We're not changing the value of it. Multiplying these, we get 3 root 2. Multiplying this, it should be root 4, which is just 2. Again, multiplying a root by itself makes the root go away. If you don't trust me, again, here is your proof. So from here on out, if you take a root by itself, just write the regular number because you don't need to put root 4. That would actually be a waste of a step. Root 8 over root 3. Root 8 over root 3. So again, we don't care about the 8. We don't like where the 3 is. So we're going to multiply by root 3. But again, to keep it from changing the value, we multiply root 3 over root 3, which then turns into root 24 over 3. Because again, a root times itself is going to equal itself. But when I go to look at 24, it looks kind of strange. 24, 4 goes into 24. It'll be 4 times 6, which means that this turns into a 2 root 6 over 3. Now, somebody's probably thinking, why can't I reduce the 6 and the 3? It goes back to your multiplication rules. That is an inside number. That's an outside number. You cannot touch them. Now, if these two were able to be reduced, you would, because they're both outside. But you do not mix inside and outside numbers in your work. But that is rationalizing. And that is going to be the tough part of your work today, which is making sure you understand what you're doing. So that's your practice. Just make sure you get into it and make sure you use similar questions as much as possible, because again, I'm not giving you 30 questions to do. That is just torture. But if you're really trying to understand the process, don't just answer all the questions and quit. If it only took you 5 minutes to do it, you might want to spend some time doing similar questions. Again, on this, the 10 is what's breaking it. So we need to multiply by root 10 on top and bottom. This turns into 5 root 60 over 10. So before I do anything with the 5 and the 10, I recognize that 60, if you remember, is 4 times 15. Think of a clock. 60 broken into 4 sections is 15 each. So that's actually root 4 times root 15, which means that's 2, which makes 10 when you multiply it, which makes 10 root 15 over 10. Well, guess what your 10s do? Because they're both outside, they cancel, giving us just root 15. And again, the power of this calculator is you can actually check your work. Again, don't use it to get the answer. Use it to check your answer, and you should be good. And then if your answer doesn't match, you can, say, hey, I don't know why my answer is not matching, or what am I doing wrong? But the whole goal is for you to get better at it. That's the key idea. Number 6, the only thing breaking this is not the 2 root 3, it is just the root 3. So there's no need to multiply by 2. We're just going to multiply by root 3 because we don't care about the 2. Numbers are okay on the bottom, radicals are not. So when we go to do this, it ends up 3 root 15. And then on the bottom, remember this root 3 times root 3 is going to be a 3, but the 2 is still down there. So it actually ends up 3 root 15 over 6. And notice 3 and 6 can both be divided by 3, so it actually turns into root 15 over 2 because 3 goes away, 6 turns into a 2. Again, this is where your practice is going to be. You want to make sure you practice enough to be fluent. What do I mean by fluent? I mean, if you're stumbling through it, if you're not sure what steps to take, you're not fluent yet. Now, if you're not moving quickly, but you at least know I'm supposed to do this step, and then you execute it appropriately, and then I'm supposed to do this step, and I execute it appropriately, that's fine. But fluent just means you're able to fluidly go through it without making any kind of major jagged stops and saying, oops, I forgot to do this, or I don't know what to do right now. So practice it until you get good at it, and that way you'll be ready when everything moves. And I will tell you, this is in Algebra 2 expectation. So actually, I think it's a geometry expectation too whenever you get into triangles for sure. Root 18 over 5. This is one fraction. Anytime you have one fraction, what you want to do with a root is split the root to be 2 of them. Now we want to get rid of the root 5 by multiplying by root 5 on top and bottom. 18 times 5 is 50 plus 40, so root 90 over 5. Hey, 90, that's a perfect number. 90 is 9 times 10, which means that this is 3 root 10 over 5 in the very end. So that is what you're practicing today. Make sure you take your time. Make sure you ask for help. Other than that, like I said, we're getting closer to the end of the year, and you don't want to cheat yourself. The finals are going to be coming, especially for those of you who might have failed the third quarter. So I wish you luck. Talk to you later.